So FM waves can be generated in two different methods. The first one is indirect method. So this figure shows the detailed block diagram for indirect method of FM wave generation. So as you can see, this is integrator and this second part is your phase modulator. So the FM wave that comes out of this block diagram is a narrowband FM wave. That means it has a bandwidth of about around 2 FM. Okay, so this narrowband FM wave can be converted to wideband FM wave using the next block diagram. Look at this. So this first part is nothing but the previous one, this much. So integrator followed by a narrowband phase modulator, which is also supplied with the crystal oscillator. So here at this point, you will have a narrowband FM wave. Now, how to convert this narrowband FM wave to a wideband FM wave is by using a frequency multiplier. So frequency multiplier is actually, it consists of two different components. First one is a non-linear device. The non-linear device can be a transistor or a diode followed by a band pass filter. So the narrowband FM wave that is generated here is applied to the frequency multiplier. So the output of frequency multiplier will be a wideband FM wave. So to understand this mathematically, let us go back to the equation. Look at this. So the output of the nonlinear device will be given by this equation. So S2 of t, if it is the output of nonlinear device is S2 of t, then and if the input is S1 of t, so the output depends on input in this fashion. Okay, so A1, A2, A3 up to AN are all constant coefficients. So if you follow this relation, what actually happens is, so that is at the output of your nonlinear device, you will have S2 of t, so which depends on your S1 of t. So here at the output of nonlinear device, you will have several frequency components. So unwanted frequency components will also be there. So some of the frequency components you will have to retain. So which one has to be retained and which one has to be removed will be taken care of by the following band pass filter. That is the second component. So the band pass filter, which is here, so it should pass the FM wave which is centered at a carrier frequency n into f1 and with frequency deviation n into delta f1, and it should suppress all the other spectral components. So one more point to be made clear is this frequency multiplier, what it actually doing is, if at all you have, that is the narrowband FM wave here, this narrowband FM wave is nothing but, so the narrowband FM wave, for example, let it be like this. We'll take this as an example. Suppose this is a narrowband FM wave. So that narrowband FM wave is available here. It has a carrier frequency, say f1, and it has a frequency deviation delta f. Okay, so the carrier frequency is f1 and the frequency deviation is delta f. So if you pass this kind of narrowband FM wave through a frequency multiplier, then the output, at the output, will there be any change on carrier frequency as well as the frequency deviation? That is the question. So definitely the answer is there will be a change in carrier frequency as well as frequency deviation. That means if you are applying a carrier frequency of F1 with frequency deviation of delta F1 at the input, at the output of frequency multiplier, the carrier frequency will be n into F1 and the frequency deviation is going to be n into delta F1. So that n is actually the multiplication factor that this multiplier is introducing. So coming back to this, so that's what is given here. So wideband FM wave is now having a carrier frequency Fc is equal to n into F1 with the frequency deviation of n into delta F1. So the final equation of wideband FM wave is the same one. Okay, so where kf is given by n into k1. So this method, what we have understood here, is actually the indirect method of FM wave generation. Now, hope you have understood the significance of frequency multiplier, and we will solve one problem on this so that it will be clear to you. Let us take this problem. So if there is an FM wave with a frequency deviation of 10 kilohertz. So what is the 10 kilohertz? That is nothing but delta F. Next, at a modulation frequency of 5 kilohertz. See, sometimes they use the word modulating or modulation frequency. Both are same. It is nothing but FM. Okay. So he has given FM, that is 5 kilohertz, is applied to two frequency multipliers connected in cascade. So the first multiplier doubles the frequency and the second one triples the frequency. Determine the frequency deviation and modulation index obtained at the second multiplier output. Also, what is the frequency separation of adjacent side frequencies of FM? So this is the question. So after understanding the problem, you have to write the corresponding block diagram. Look at this. He has given that there are two different multipliers, frequency multipliers, which are connected in cascade. The first one will double, the second one will triple the frequency. So what else he has given? He has given the details such as frequency deviation and message signal frequency at the input. So these are the specifications of the signal which are applied at the input. Okay, so let us write FM wave you are applying here. So this is a narrowband FM wave. So you will get a wideband FM wave at the output of the frequency multiplier. So again, that wideband depends on the factor n. Okay. For the given problem, delta F is 10 kilohertz, FM is 5 kilohertz. Now, what will be the intermediate signal at the output of first frequency multiplier? That is the question. See, let us call this factor as n1. So n1 is equal to 2. So as I have already explained, at the output of frequency multiplier, the frequency deviation should change. Okay. He has not mentioned carrier frequency here. So just leave it. So will the frequency deviation be affected by a carrier by the multiplier? Yes, it will be affected. So here it is not going to be delta F, it has to be different, delta F1. Okay, so delta F1 is equal to N1 into delta F. So that is what is written here. Okay, next frequency multiplier is with multiplication factor equal to 3. So let us call it as N2 is equal to 3. So finally you will have an FM wave which is of different frequency deviation. Let us call it as delta F2. So now what all he has asked is, coming back to question, frequency deviation at the output should be determined and also modulation index. Okay, so he is asking delta F2 as well as beta. So you have understood how we have obtained delta F1. This is nothing but this one, 2 into 10 kilohertz. Next, Similarly, find out delta F2. Delta F2 is equal to N2 into delta F1. That is this one. N2 into delta F1. So that you will get at the output. So delta F2 is equal to 60 kilohertz. Next, how do you determine beta? So the total modulation index. That is going to be the output frequency deviation delta F2 divided by Fm. Fm will not change. That is the original message signal frequency. So don't write it as n into Fm. It's not going to change. It is the original Fm. Okay. So the total modulation index at the output is going to be delta F2 by Fm, which gives you 12. So beta is 12 now. So he has asked one more question. What should be the frequency separation between adjacent side frequencies? So this I have explained in this figure. That is nothing but he's asking what is the separation between any two adjacent frequency components here. So it is nothing but Fm. So you have to write the answer Fm. So that is nothing but 5 kilohertz will be the frequency separation. Hope you have understood this problem. So if this question is asked, that is explain indirect method of FM wave generation. We also call it as Armstrong method. Please note it down. It is also called as Armstrong method of FM wave generation. So this question can be asked for maximum 7 marks, 7 to 8 marks. Then you will have to write this block diagram followed by these two as well as explanation with relevant equations. Okay. Finally, this output FM wave equation. Okay. Such problems can be asked for maximum 4 marks. So next, after this, I'll be explaining a design problem based on Armstrong method.